Let's look at a problem of transient analysis of a circuit which is having only R and L components. We will try to do three different kinds of problem. One is a circuit having RL components only. Second is a circuit having RL, R and C components only. And the third one will be for a circuit having RLC component, all of them together in a single circuit. So out of that, the first one is the transient analysis of RL circuit. Now let's read the question and understand what the question is. In the network shown, the switch is moved from 1 to 2 at t is equal to 0. So at t is equal to 0, you are having the switch moved from position 1 to 2. Before that, what was the condition? After steady state has been established in position 1. That means when the switch was in position 1, the steady state had been established. That means it had been connected to switch 1 for a long time. And after that, at t is equal to 0, the steady state, at t is equal to 0, the switch is moved from 1 to 2. So there are, as you can see, two different timings here. One is the time before t is equal to 0, and the other is after t is equal to 0. So whatever is happening before t is equal to 0 has come to a steady state, and whatever is happening after t is equal to 0 we want to find out. This distinction has to be clearly understood. What did I say? I said that there are two times or time periods. One is before t is equal to 0, where steady state had been achieved, and the time after t is equal to 0, where you want to find out I of t. So we know that for finding out this I of t at t is equal to 0, we will have to solve using mesh. Or let's say nodal or superposition or simple KVL, whatever is the case. But for solving the circuit, we need to change the L component. How? So let me draw it in a clean slate. So let me cut it off. Okay, the thing is, I want to draw the circuit at or after t is equal to 0 or t greater than 0. So at that point, this switch is going to be connected here. So after that, the switch will be connected here. So I will draw it like this. The switch is connected at position 2. Now position 1, whatever is the circuit portion, that is not there, but still I will draw it just for reference point of view. This portion, but see, this portion is not connected to the circuit, so we can say that this will not be a part of the circuit. Let it remain there. Then we are having the remaining portion, which is 1 ohm resistor. Similarly here it is 1 ohm. Then we are having the inductor. Now before t is equal to 0, was the inductor in the circuit charged? Yes, it is charged. Why? Because before t is equal to 0, the switch was at position 1. So the circuit that was connected was this 10 volt connected via this switch to a resistor and an inductor. The value of inductor here I forgot to write, let it be 1H. Yeah. So the inductor and the resistor are connected to the battery. At this time, that means before t is equal to 0, this portion is not connected. So yes, the inductor had been charging. So since the inductor had been charging, I told you we will write an inductor with a voltage source. Now what is the voltage source? The voltage source will depend on the current flow. As you can see, since 10 is having positive here, so the current should have been flowing in this direction. So it is flowing in this direction, so I will write the polarity as minus and plus here. Now in this circuit, L is 1H, so this is L, and we know that the inductor, after charging, we will have inductor and the voltage source, where the value of inductor I will write it as Ls. Here L is 1, so it will be just S. And the voltage, if you remember, we had written Li naught. L is 1, so I will just write I naught. So to solve and find out what is the current that is going to be, see, determine I of t. What is I of t? I forgot to again write here. I of t is this current, I of t. Okay. So if we want to find out I of t, then this is no issue because 1 ohm is here. Here also 1 ohm is there. S is okay. But what about I0? What is the value of this particular voltage source? After knowing that only I will be able to solve I of t. So the first thing should be to find I of 0. That means that value of current that was flowing in this circuit, in this charging circuit, at the time period just before t is equal to 0. So I will write first. So the solution basically does not start from here. It starts from, first is part 1. Okay. Part 1, where find I naught or I naught minus. So how do we find out? For that we have to consider what current is passing through the inductor. Now when I am considering that, I am talking of the case where it is already in steady state, or we can say final state. So in final state, nothing happens to the resistor because the resistor is always the same, 1 ohm. But what happens to the inductor? The inductor is short circuit, and then we are having the remaining portion, which is just the connection. This is 10 volt. Remember, we are not going to take into consideration the resistor here. The resistor here I am not going to take into consideration, because I am not going to take into consideration this 1 ohm resistor because it's not part of the circuit. It's not connected anywhere. Now I want to find out what is this current. That current will be I naught minus. It is very easily, you can see here, I naught minus is equal to 10 volt divided by 1 ohm resistor, which is 10 amps. So your I naught is 10 amps. Then we will do the second part. Which is part 2. In part 2, we need to find out, as I told you previously, we need to find out I of t at t greater than 0. That is the answer that we want to find out, isn't it? So we use this particular circuit. Let me draw this circuit here. So now the value of I naught is very well known, which is 10 amp. So I will directly write that 10 amps here. The value of L is 1, I naught is 10. So this is 10 volt. So this is the new circuit after t greater than 0, and for that we have to find out I of t. Now it is very simple. All we have to do is write the KVL. So KVL for mesh gives me, so the current is flowing like this, so this is plus, minus, plus, minus, plus, minus. Let me take the back of the component. So back of the component means, so it will be plus of 1 into IT. So plus of IT, I of t. Now if I am going to write like this, the issue is that here I am having the equation to be having Laplace component s, whereas only the value of I of t is in time, rest everything is Laplace. So Remember this very carefully. The value of I of t becomes the Laplace value of I of t, which is I of s. So I will not be using I of t. I will be using instead I of s. Always remember that is to be done. You cannot solve it with respect to time. You have to solve it with respect to Laplace. Okay. So here I am having I of s. So now if I write the equation, so it will be I of s into 1 plus I of s into 1 plus s I of s, and then minus 10 is equal to 0, from which I will get 2 plus s I of s is equal to 10, or I of s is equal to 10 by s plus 2. We know that the Laplace inverse of I of s, Laplace inverse of I of s, let me write Laplace inverse of I of s is going to give me I of t. Therefore, I do the Laplace inverse of 10 by s plus 2. We know that the Laplace inverse of 10 by s plus 2 is, the constant 10 comes outside. The Laplace of 1 by s plus 2 is e raised to power minus 2t u of t. U of t basically means for time period t greater than 0. So I can write, so this is I of t. So I can write I of t is going to be equal to 10 e raised to power minus 2t for t greater than 0. Why didn't I write u of t? Well, nothing. It's only because I have already written here for t greater than 0. So there is no point in writing u of t. So that is going to be the answer that we have been asked.